Hello guys, today I'm gonna discuss to you the chapter 11 of the CCNA 7 Bridging, Switching, Routing, and Wireless Essentials. First, we have the implement port security. We go to the secure unused ports and secure unused ports. Layer 2 devices are considered to be the weakest link in a company's security infrastructure. Layer 2 attacks are some of the easiest for hackers to deploy, but these threats can also be mitigated with some common Layer 2 solutions. All switch ports interfaces should be secured before the switch is deployed for production use. How a port is secured depends on its function. There's a simple method that many administrators use to help secure the network from unauthorized access is to disable all unused ports on a switch. For example, if a Catalyst 2960 switch has 24 ports and there are 3 fast Ethernet connections in use, it is good practice to disable the 21 unused ports. Navigate to each unused ports and issue to the Cisco IOS 2 shutdown command. If port must be reactivated at a later time, it can be enabled with no shutdown command. And to configure range of ports, you should use the interface range command, which is the switch config interface range type module / first number and last number of the switch. For example, to shutdown ports for FA08 through F0 to 24 on switch 1, you would enter the following command. Here, you can see here the S1 config, here the user interface range FA08 to 24, and then hit enter, then type shutdown, and you'll see here the interface password 0 change state to administratively down. It means the F8A020 F808 has been shut down, or it has been shut down. Next is the mitigate MAC address table attacks. The simplest and most effective method to prevent MAC address table overflow attacks is to enable port security. Port security limits the number of valid MAC addresses allowed on a port. It allows an administrator to manually configure MAC addresses for a port or to permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secure source MAC addresses that were manually configured or dynamically learned on the port. By doing that, you can limit the number of permitted MAC addresses on a port to 1. Port security can be used to control unauthorized access to the network as shown in this figure. You can see here this figure. The port security has been limited to 1. Next is the enabled port security. Here you can see here an example of the switch port security command that was being rejected. This is because port security can only be configured on manually configured access ports or manually configured trunk ports. By the default, layer 2 switch ports are set to dynamic auto or tracking on, and therefore, in this example, the port is configured with the switch port mode access interface configuration command. To do that, use the show port security interface command to display the current port security settings for fast Ethernet 01. As shown in the examples here, you'll notice how port security is enabled. The violation mode is shut down here, and the maximum number of MAC addresses is only 1. If a device is connected to the port, the switch will automatically add the device's MAC address as a secure MAC. In this example, no device is connected to the port, or there's no end devices is connected. Next is the limit and learn MAC address. We have here the three ways of how the switch can be configured to learn about the MAC addresses on a secure port. First, we have manually configured. Means the administrator manually configures a static MAC addresses by using the following command for each secure MAC address on the port. Here you can see the command that the user used. And next is the dynamically learn. When the switch port security command is entered, the current source MAC address for the device connected to the port is automatically secured, but is not added to the startup configuration. Third is the dynamically learn sticky. The administrator can enable the switch to dynamically learn the MAC address and stick them to the running configuration by using the following command. Here you can see the command that has been used, which is the switch config if switch port security to MAC address and sticky. Next is the port security aging. There are two types of port security aging that supported per port. First is the absolute. This is the secure addresses on the port are deleted after the specified aging time. Next is the inactivity. Secure addresses on the port are deleted only if they are inactive for the specified aging time. This means that in the absolute is deleted after doing after setting an specified aging time. The inactivity, the secure addresses on the port will only be deleted only if they are inactive for the specified aging time. Next is the port security violation mode. Here you can see the mode of the security violation mode descriptions. Here you can see the shutdown. Shutdown means the port transitions to the error disabled state immediately. Turns off the port LED and sends a syslog message. It increments the violation counter when a secure port is in the error disabled state. An administrator must re-enable it by entering the shutdown and no shutdown commands. Next is the restrict mode. The port drops packets with unknown source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. This mode causes the security violation counter to increment and generates a syslog message. Next is the protect. This is the least secure of the security violation modes. The port drops packets with unknown MAC source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value, and there will be no syslog message sent. Here you can see here the security violation mode comparison. This is the violation mode, the protect, restrict, shutdown, and if it's the discard of any traffic, the protect yes, restrict yes, shutdown yes, and sends this log message. The only one that not send syslog message is the protect, which you can see the no and restrict for yes, shutdown yes. Increase violation and counter, protect no, restrict yes, shutdown yes. Shutdown port, protect no, restrict no, shutdown yes. Next is the port in error disabled. You can see here the following commands here. In this example, the show interface command identifies the port status as ERR disabled. The output of the show port security interface command now shows the port status as secure. Shut down the security violation counter increments by 1. Here's the verification of the port security. You see here how to verify the user must put show port security and the switch port security will appear here. Let's see here some commands. Next, we'll go to the 11.2 of the chapter 11, which is the mitigate VLAN attacks. Go to the VLAN attacks. We go to steps to mitigate VLAN hopping attacks. The step to mitigate VLAN hopping attacks is first, you have to disable the DTP auto trunking negotiations on non-trunking ports by using the switch port mode access interface configuration command. Next is step 2. Disable unused ports and put them in an unused VLAN. Step 3 is to manually enable the trunk link on a trunking port by using a switch port mode trunk command. Step 4. Disable DTP auto trunking negotiations on trunking ports by using the switch port no negotiate command. Lastly is the step 5, which is the set the native VLAN to a VLAN other than VLAN 1 by using the switch port trunk native VLAN and the VLAN number command. You can see here the example of how to set up that. Here's the actual interface of how it goes. This is the how to configure the VLAN hopping attack. Next, we go to the chapter 11.3 of the chapter 11. We go to DHCP snooping. What is DHCP snooping? This is DHCP snooping does not rely on source MAC addresses. Instead, DHCP snooping determines whether the DHCP messages are from an administratively configured trusted or untrusted source. If then filters DHCP message and rate limits DHCP traffic from untrusted source. Devices under your administrative control such as switches, routers, and servers are trusted sources. And in devices beyond the firewall or outside your network is untrusted sources. Or we could say that it might be an attacker. In addition, all access ports are generally treated as untrusted sources. The figure shows here is an example of the trusted and untrusted ports. You can see here the legend, the violet for trusted port and red for the untrusted ports. Here you can see here, oh, I'm right. The untrusted ports might be the attacker. And here are the steps to implement DHCP snooping. First, you have to enable DHCP snooping by using the IP DHCP snooping command global configuration. And step 2, on trusted ports, use the IP DHCP snooping trust interface configuration command. Third is to limit the number of DHCP discovery messages that can be received per second on untrusted ports by using the IP DHCP snooping limit rate interface configuration command. Lastly is to enable DHCP snooping by VLAN or by a range of VLANs by using the IP DHCP snooping VLAN global configuration command. Here are the example of the DHCP snooping configuration. See here the untrusted ports. You can see here the interface, the commands that use. Here you can see here the mechanism. Oh, this syntax check. Next we go to the 11.4, which is the mitigate ARP attacks. Dynamic ARP inspection. In a typical ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. To prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are delayed. Dynamic ARP inspections that requires DHCP snooping and helps prevent ARP attacks by here's the not relying invalid or gratuitous ARP replies out to other ports in the same VLAN, intercepting all ARP requests and replies on untrusted ports, verifying each intercepted packet for a valid IP2 MAC binding, dropping and logging ARP replies coming from invalid to prevent ARP poisoning, error which disabling an interface if the configured DAI number of ARP packets exceeded. Next is the DAI implementation guidelines. To mitigate the chances of ARP spoofing and ARP poisoning, follow these DAI implementation guidelines. First, you need to enable DHCP snooping globally. And enable DHCP snooping on selected VLANs only. Enable DAI on selected VLANs only too. Configure trusted interfaces for DHCP snooping and ARP inspection. And it is generally advisable to configure all access switch ports as untrusted and to configure all uplink ports that are connected to other switches as trusted. Here is the sample topology in the figure, which identifies the trusted and untrusted ports. Here you can see the example of configuration, the configuration, the interface, and the command that has been used. Next is we go to the mitigate. Lastly is the mitigate STP attacks, which is 11.5. Go to the port fast and BPDU guard. Here in the port fast and BPDU guard, you can see the port fast means the port fast immediately brings an interface configured as an access or trunk port to the forwarding state from a blocking state by passing the listening and learning states. Apply to all end users ports, and port fast should only be configured on ports attached to end devices. And the BPDU guard is immediately error disables a port that receives a BPDU like port fast. BPDU guard should only be configured on interfaces attached to end devices too. You could see the access port for S1 should be configured with port fast and BPDU. Let's see here, the switch or PCs. Yeah, here the switch are access points. And configure port fast. Here's the example of how to configure the port fast. This is the command that has been used. See here, it used the STP2. Next is the configure BPDU guard. Here are the configuration, the commands that has been used. That's all guys for this chapter. Thank you.